Hello students, welcome back to Algebra 2. Today we're going to be talking about the focus of a parabola. So if we consider a parabola, we have a shape that looks in general something like this. On the inside of the parabola, there exists a point. This is called the focus. The neat thing about the focus is that when something enters into a parabola, for example, light. If light came into a parabola, it would hit the parabola and it would bounce off and it would enter into the focus. And no matter what direction the light came from, it would bounce into the focus. This fact is used for things like solar panels that want to collect light. They calculate the shape of the parabola, they calculate where the focus should be, and then they put a collector right where the focus is, knowing that all of that is going to go there. Another use of this is long distance microphones. Someone could create a parabolic dish like this that has a microphone right there. So that way the sound would go into the parabola and then bounce off into the vertex, allowing you to hear more sound. Now, the focus also works in the opposite direction. So if we have a parabola right here, this is actually very useful for speakers. If the focus is right here, what happens is this speaker could make noise going in all directions. But what happens is the noise will come out this way and it'll exit the speaker. But if this focus right here is generating sound in all directions, this, if it went backwards, it would bounce off and then come out in a parallel line so that all of the sound would be focused in the same direction. Just like that. So, parabolas and the focus of the parabola has a lot of real-world use here. Now, there is another piece of the parabola that becomes very useful to us when we are writing equations for modeling with this. So, I'm going to go ahead and draw this again. And right there, that is the vertex of the parabola, and directly above the vertex is something called the focus. Now, between the parabola and the focus is a certain distance depending on the parabola, and we call that distance p. Doesn't stand for anything, it's just we needed to give it a letter. Now, if we take that p-value there and continue it through right here, we will get another line that goes through p like that at 90 degrees. And this line right here is called the directrix. Now, the interesting thing about the directrix is that if I pick any point on the parabola and go straight down, I will get a distance. And that distance on a parabola will always be the same from this point to the directrix. That will be the same distance as that same point to the focus. So these two will always be the same. Now, on my picture here, that doesn't exactly look right because I didn't take the time to draw a proper parabola. But this fact right here, the fact that the distance from the point to the directrix is the same as the point to the focus, can be very useful. Quick geometry review. We will be using the distance formula. And if you don't remember this, that's okay. So if I have 2 points, x1, y1, and another point, x2, y2, the distance between those two is the square root of x2 minus x1 squared plus y2 minus y1 squared. We'll be using that formula. So, for example, using the distance formula to write an equation. So let's use this distance formula to write the equation of the parabola with the focus f, 0, 2, and the directrix y equals -2. So I'm just going to draw a picture of that real quick. So if I have my coordinate plane right here, the focus is at 0, 2, which would be right here, and the directrix is at y equals -2. Now I know that the vertex is going to be directly in between the focus and the directrix, so I know that the vertex is going to be right here at 0, 0. And that's nice because that means I don't have to worry about any horizontal or vertical translations. I know that it's just right there on 0, 0. Okay, so I'm going to go ahead and draw a parabola here. I don't know what that is, but this is just a generic parabola. Now, on that parabola, I am going to pick a point. That point right there is just going to be x, y. I'm just going to label this right here, f0, 2. So I want to use the distance formula to figure out what the equation of this parabola is. So I've got two distances that I need to compare. The first one is the distance from the focus to this point. The second one is the distance from the point going straight down at 90 degrees to the directrix. So I've got this point right here. So we have to stop and think for a second, what are the coordinates of that point? So I know that the y value is going to be -2 because it's on the line y equals -2. But how much did I go right to get to that point? Well, I went right x. Okay, so let's go ahead and call this point, we'll just call it point A. So that means, and we'll call this point D for directrix, that the distance from A to F should be equal to the distance from A to D. And just a quick reminder, the distance is equal to the square root x2 minus x1 squared minus plus y2 minus y1 squared. So for AF, we will say that this is x2 and y2, and this F right here is x2 and y1. So I've got the square root of x minus 0 squared plus y minus 2 squared. That's going to be equal to the distance from A to D. So that would be the square root of x minus x squared plus y minus -2 squared. Okay, so simplifying that a little bit, I'm going to get the square root of x squared, then y minus 2 squared. I actually need to calculate that. Y minus 2, y minus 2. You get y squared minus 2y minus 2y plus 4. So that means I'm going to get x squared plus y squared minus 4y plus 4 is equal to, right here, x minus x is 0, and 0 squared is 0. So that's just going to go away. Y minus negative 2 is going to be y plus 2 squared. So I'm going to do the same thing. Y plus 2, y plus 2, y squared plus 2y plus 2y plus 4. So I'm going to get the square root of y squared plus 4y plus 4. So now I just need to solve this equation. I see I've got square roots on both sides, so I can just quickly square both sides, and that's going to cancel out the square roots. So I get x squared plus y squared minus 4y plus 4 is equal to y squared plus 4y plus 4. So now I can see I've got y squareds on both sides, so I can subtract y squared. I've also got 4's on both sides, so I can subtract 4. And then I can add 4y on both sides. So I see these will cancel out, this 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 will turn into an 8y. So I end up with x squared is equal to 8y, and my equation should look like y equals something. So I'm going to get the y by itself by dividing by 8, and I get y is equal to x squared over 8, or 1/8 x squared.